Geometric sequences. Recall, a geometric sequence is a sequence of numbers with a common ratio. The sequence can be written in this form here. A sub 1, a sub 1 times r, a sub 1 times r squared, a sub 1 times r cubed, and so on, where a sub 1 is the first term of the sequence and r is the common ratio. Here's an example. Let's find the next term and state the common ratio. Alright, so here, to figure out the common ratio, you just have to ask, what do you multiply by 3 to get 6? Well, you multiply it by 2 times 2. So the common ratio is 2. So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48, which is the next term. Here, what do you have to multiply 32 by to get negative 16? Well, that's negative 0.5. Multiply 32 times negative 1/2 and you get negative 16. Negative 16 times negative 1/2 is 8. 8 times negative 1/2 is negative 4. And negative 4 times negative 1/2 is 2. Here we have 16 and then 24. So you multiply 16 by 1.5 to get 24. 24 times 1.5 is 36. 36 times 1.5 is 54. And 54 times 1.5 is 81. Write the first 4 terms of the geometric sequence that's described. The first term is 10, so we begin with 10. Then we multiply that by 0.5. 10 times 0.5 is 5. 5 times 0.5 is 2.5. 2.5 times 0.5 is 1.25. Here we start with the first term of 36. We multiply that by 2/3. 2/3 times 36 is 24. 2/3 times 24 is 16. 16 times 2/3 is 32/3. Here is explicit function form. A sub n equals a sub 1 times r to the n minus 1 power, where n is the term number in the sequence and r is the common ratio. Find the 8th term of the geometric sequence with a sub 1 equal to 5 and r equal to 3. We start with our formula and we plug in 5 for a sub 1 and 3 for r. And n is going to be 8 because we're finding the 8th term. So that becomes the 7th power. 3 to the 7th times 5 is 10,935. Find the common ratio r if a sub 7 equals 364.5 and a sub 1 equals 0.5. Alright, so we're going to start with our formula, which I'll paste in right here. Alright, so if a sub 7 equals 364.5, so we're going to set up the equation for a sub 7. So a sub 7 is 364.5 equal to a sub 1, which is 0.5, times r to the 7 minus 1 power. And then we solve for r. So we have r to the 6th equal to 729 because we divided both sides by 0.5. Then we take the 6th root of 729 and we see that r equals 3. Moving on, find n if a sub 1 equals 3 and a sub n equals 234,375 and r equals 5. First step is we're going to be pasting in our equation. Alright, so a sub n right here is 234,375. So I'm going to put that right here on the left side of the equation. A sub 1 is 3 and r is 5. So we're looking for this n minus 1 exponent up here. We're going to solve for this exponent. Alright, so we're going to divide both sides by 3. Then we're going to take the log of both sides. When we do that, we see we have log of 78,125 on the left, and we can bring this exponent down in front, so we have n minus 1 times log of 5. Divide both sides by log 5, set that equal to n minus 1, and we see that this equals 7. So 7 equals n minus 1, or n equals 8.